Now I am going to discuss about 12th physics. What is the SI unit of conductance? Ohm meter, mho. What is the SI unit of conductance? Is the ohm inverse. SI unit of conductance is ohm inverse. Next, the relation between kilowatt hour and joule. The relation between kilowatt hour and joule. 1 kilowatt hour equal as joule. 1 kilowatt hour equal 3.6 into 10 to the power 6 joule or 36 into 10 to the power 5 joule. If the thickness of a wire increases, if the thickness of wire increases, what happens to its resistance? If the thickness of the wire increases, then the resistance will decrease. If the thickness of wire decreases, then the resistance will increase. Next, a wire of 4 ohm is half and two pieces are joined in parallel. Find its resistance. Repeat the question. A wire of 4 ohm is half and two pieces are joined in parallel. Find its resistance. A wire of 4 ohm is half means each pieces getting resistance by 2 ohm and 2 ohm. When they are connected in parallel, the net resistance will be 1 ohm. 1 by 2 plus 1 by 2, 2 by 2, which is 1 ohm. Name the substance whose temperature coefficient of resistance is 0. Name a substance whose temperature coefficient of resistance is 0. Manganese. Next question. What is the relation between current and current density vector? What is the relation between current and current density vector? Current I equal to J into A in a particular direction, where I equal to current, J equal to current density vector, A equal to area vector. Express volt in terms of ampere and watt. Express volt in terms of watt and ampere. Volt equal to watt by ampere. 1 volt equal to 1 watt per 1 ampere. Define 1 start ohm. Define 1 start ohm. 1 start ohm is the resistance of a conductor through which 1 start ampere current flows due to the potential difference of 1 start volt across its ends. Next, what is steady current? The steady current is the current whose magnitude and direction are not changed. Next, calculate the potential difference required to maintain a current of 5 milliampere in a 400 ohm resistance. Calculate the potential difference required to maintain a current of 5 milliampere in a 400 ohm resistance. It is here given. I equal to 5 milliampere, which is 5 into 10 to the power minus 3 ampere, and resistance equal to 400 ohm. You have to find the potential difference, means you have to find the V. V equal to IR. I equal to 5 into 10 to the power minus 3 ampere into R equal to 400, which is 2 volt. Define conductance. Conductance is defined as the reciprocal of resistance of conductor. Conductance is the reciprocal of resistance. It is given by conductance is written by denoted by capital G. Capital G is equal to I by R, which is R is the resistance of the conductor. Current I, G equal I by R. Define resistivity. Resistivity is defined as the resistance of a conductor of unit length and unit area of cross section, which is given by rho equal to R into A by L. R is the resistance, A is the area of cross section, L is the length of the conductor. Who has given the law relating to the heating effect of electric current? Joule. Correct the relation on the volt equal to ampere by ohm. Is it correct? Volt equal to ampere by ohm. No, volt equal to ohm into ampere. Write the relation between Weber and Maxwell. Weber and Maxwell, 1 Weber equal to 10 to the power 8 Maxwell. 1 Weber equal to 10 to the power 8 Maxwell. What is the angle between the magnetic index MI, magnetic induction, and the normal to the plane of a coil in the moving coil galvanometer? What is the angle between the magnetic induction and the normal to the plane of a coil in the moving coil galvanometer? Where theta is 0 degree. Define electric power. Define electric power. Electric power is defined as the rate of consumption of electrical energy. Next, what happens to the heat produced if the resistance of a conductor is doubled? If the resistance of the conductor is doubled, then what happens to the heat? R equal to double. Next question. What is the direction of conventional current? The direction of a conventional current in the opposite direction of a flow of negative charge. Or you can say opposite direction of a flow of electrons. Next. A charge of 240 coulomb passes in 2 minutes through an electric heater. Find the current flow through it. A charge of 240 coulomb passes in 2 minutes through an electric heater. Find the current flow through it. What are given in this question? A charge of 240 coulomb passes in 2 minutes. That means Q charge is given 240 coulomb. T 2 minutes. That can be converted into second. Time here is 120 seconds, and you have to find the current flow through it. I equal to Q by T, 240 volt by 120 seconds, that is 2 ampere. Define conductivity. Conductivity is defined as the conductance of a conductor of unit length and unit area of cross section. So conductivity is given by G into L by A. G is the conductance, L is the length of the conductor, and A is the area of cross section of the conductor. Write the velocity relation between potential difference and drift velocity. The drift velocity equal EP by ml into tau. Next, What happens to the conductivity of a conductor if it is cut into three pieces? The conductivity remains unchanged. Next, name two substances whose temperature coefficient of resistance is negative. Name two substances whose temperature coefficient of resistance is negative. Germanium and silicon. Define mobility of ions. Give its unit. Define mobility of ions. Give its unit. Mobility of ion is defined as the ratio between drift velocity and electrified intensity. Mobility mu equal to velocity upon intensity E. Unit is coulomb per meter by Newton per second. Coulomb meter by Newton second. What is the unit of current density vector? The SI unit of current density vector is ampere per meter square. Relation between ampere and start ampere. 1 ampere equal to 3 into 10 to the power 9 start ampere. 1 ampere equal to 3 into 10 to the power 9 start ampere.